Hi, I'm Rich Bibby with RealPython.com. Python is famous for allowing you to write code that's elegant, easy to write, and almost as easy to read as plain English. One of the language's most distinctive features is the list comprehension, which you can use to create powerful functionality within a single line of code. However, many developers struggle to fully leverage the more advanced features of a list comprehension in Python. Some programmers even use them too much, which can lead to code that's less efficient and harder to read. So by the end of this tutorial, you'll understand the full power of Python list comprehensions and how to use their features comfortably. You'll also gain an understanding of the trade-offs that come with using them so that you can determine when other approaches are more preferable. In this tutorial, you'll learn how to rewrite loops and map calls as a list comprehension in Python, choose between comprehensions, loops, and map calls, supercharge your comprehensions with conditional logic, use comprehensions to replace filter, and profile your code to solve performance questions. So let's get started. One way to create lists in Python is using loops, and the most common type of loop is the for loop. You can use a for loop to create a list of elements in 3 steps. Step 1 is instantiate an empty list. Step 2 is loop over an iterable or range of elements. And step 3 is to append each element to the end of the list. If you want to create a list containing the first 10 perfect squares, then you can complete these steps in 3 lines of code. Here you instantiate an empty list called squares. Then you use a for loop to iterate over the range 10. Finally, you multiply each number by itself and append the result to the end of the list. Map objects provide an alternative approach that's based in functional programming. By the way, you can learn all about functional programming in Python in another course here at RealPython. You pass in a function and an iterable, and map will create an object. This object contains the output that you would get from running each iterable element through the supplied function. As an example, consider a situation in which you need to calculate the price after tax for a list of transactions. Here you have an iterable, txns, and a function, getPrice with tax. You pass both of these arguments to map and store the resulting object in final prices. You can easily convert this map object into a list using list. List comprehensions are a third way of making lists. Rather than creating an empty list and adding each element to the end, you simply define the list and its contents at the same time by following this format. Every list comprehension in Python includes 3 elements: the expression, the member, and the iterable. And I'll explain each of these when we step through an example in a second. With this elegant approach, you can rewrite the loop from the last example in just a single line of code. As I said, every list comprehension in Python includes 3 elements. Expression is the member itself, a call to a method or any other valid expression that returns a value. In this example, the expression I multiplied by I is the square of the member value. Member is the object or value in the list or iterable. In this example, the member value is I. An iterable is a list, set, sequence, generator, or any other object that can return its elements one at a time. In this example, the iterable is range 10. A list comprehension in Python works well in many places where you would use map. You can rewrite the pricing example with its own list comprehension. The only distinction between this implementation and map is that the list comprehension in Python returns a list, not a map object. List comprehensions are often described as being more Pythonic than loops or map. But rather than blindly accepting that assessment, it's worth it to understand the benefits of using a list comprehension in Python when compared to the alternatives. Later on, you'll learn about a few scenarios where the alternatives are actually a better choice. One main benefit of using a list comprehension in Python is that it is a single tool that you can use in many different situations. In addition to standard list creation, list comprehensions can also be used for mapping and filtering. You don't have to use a different approach for each scenario. This is the main reason why list comprehensions are considered Pythonic, as Python embraces simple, powerful tools that you can use in a wide variety of situations. As an added side benefit, whenever you use a list comprehension in Python, you won't need to remember the proper order of arguments like you would when you call map. List comprehensions are also more declarative than loops, which means they're easier to read and understand. Loops require you to focus on how the list is created. You have to manually create an empty list, loop over the elements, and add each of them to the end of the list. With a list comprehension in Python, you can instead focus on what you want to do in the list and trust that Python will take care of how the list construction takes place. So now that you understand some of the benefits of using list comprehensions, in the next lesson you'll gain a more in-depth understanding of the full value that list comprehensions provide by exploring their range of possible functionality. In order to understand the full value that list comprehensions can provide, it's helpful to understand their range of possible functionality. You'll also want to understand the changes that were made to list comprehension in Python 3.8, so we'll cover these off also. Firstly, let's look at using conditional logic. In the previous lesson, you saw this formula for how to create list comprehensions. While this formula is accurate, it's also a bit incomplete. A more complete description of the comprehension formula adds support for optional conditionals. The most common way to add conditional logic to a list comprehension is to add a conditional to the end of the expression. Here, your conditional statement comes just before the closing bracket. Conditionals are important because they allow list comprehensions to filter out unwanted values, which would normally require a call to the filter function. Let's have a look at an example. In this code block, the conditional statement filters out any characters in sentence that aren't a vowel. The conditional can test any valid expression. If you need a more complex filter, then you can even move the conditional logic to a separate function. Here you create a complex filter called isConsonant and pass this function as the conditional statement for your list comprehension. Note that the member value I is also passed as an argument to your function. You can place the conditional at the end of the statement for simple filtering. But what if you want to change a member value instead of filtering it out? In this case, it's useful to place the conditional near the beginning of the expression. With this formula, you can use conditional logic to select from multiple possible output options. For example, if you have a list of prices, then you may want to replace negative prices with 0 and leave the positive values unchanged. Here, your expression I contains a conditional statement. If I is greater than 0, else 0. This tells Python to output the value of I if the number is positive, but to change I to 0 if the number is negative. If this seems overwhelming, then it may be helpful to view the conditional logic as its own function. Now your conditional statement is contained within the getPrice function, and you can use it as part of your list comprehension expression. While the list comprehension in Python is a common tool, you can also create set and dictionary comprehensions. A set comprehension is almost exactly the same as a list comprehension in Python. The difference is that the comprehensions make sure that the output contains no duplicates. You can create a set comprehension by using curly braces instead of brackets. Your set comprehension outputs all the unique vowels it found in quote. Unlike lists, sets don't guarantee that items will be saved in any particular order. Dictionary comprehensions are similar, with the additional requirement of defining a key. To create the squares dictionary, you use curly braces, as well as a key value pair. I multiplied by I in your expression. Python 3.8 introduced the assignment expression, also known as the walrus operator. It allows you to run an expression while simultaneously assigning the output value to a variable. To understand how you can use it, let's have a look at an example. Say that we need to make 10 requests to an API that will return temperature data. You only want to return results that are greater than 100 degrees Fahrenheit. Assume that each request will return different data. In this case, there's no way to use a list comprehension in Python to solve the problem. The formula expression for member in iterable, if conditional, provides no way for the conditional to assign data to a variable that the expression can access. The walrus operator solves this problem. As I already mentioned, it allows you to run an expression while simultaneously assigning the output value to a variable. Let's have a look at this in an example. In this case, we're going to use the getWeatherData function to generate fake weather data. You won't often need to use the assignment expression inside of a list comprehension in Python, but it's a useful tool to have at your disposal when necessary. So now you know how to supercharge your list comprehensions and how useful they can be, but it's also important to understand that there are certain circumstances in which they are not the right choice. In the next lesson, you'll learn when not to use a list comprehension in Python. List comprehensions are useful and can help you write elegant code that's easy to read and debug, but they're not the right choice for all circumstances. For example, they might make your code run more slowly or use more memory. If your code is less performant or harder to understand, then it's probably better to choose an alternative. Firstly, we need to watch out for nested comprehensions. Comprehensions can be nested to create combinations of lists, dictionaries, and sets within a collection. For example, say a climate laboratory is tracking the high temperature in 5 different cities for the first week of June. The perfect data structure for storing this data could be a Python list comprehension nested within a dictionary comprehension. You create the outer collection temps with a dictionary comprehension. The expression is a key pair value, which contains yet another comprehension. This code will quickly generate a list of data for each city in cities. Nested lists are a common way to create matrices, which are often used for mathematical purposes. Let's take a look at another code block for this. The outer list comprehension, 4 underscore in range 6, creates 6 rows, while the inner list comprehension, I for I in range 5, fills each of these rows with values. So far, the purpose of each nested comprehension is pretty intuitive. However, there are situations such as flattening nested lists where the logic arguably makes your code more confusing. Take this example, which uses a nested list comprehension to flatten a matrix. The code to flatten a matrix is concise, but it may not be so intuitive to understand how it works. On the other hand, if you were to use for loops to flatten the same matrix, then your code will be much more straightforward. Now you can see that the code traverses one row of the matrix at a time, pulling out all the elements in that row before moving on to the next one. While the single-line list comprehension might seem more Pythonic, what's most important is to write code that your team can easily understand and modify. When you choose your approach, you'll have to make a judgment call based on whether you think the comprehension helps or hurts readability. Okay, let's look at why we should choose generators for large datasets. A list comprehension in Python works by loading the entire output list into memory. For small or even medium-sized lists, this is generally fine. If you want to sum the squares of the first 1,000 integers, then a list comprehension will solve this problem admirably. But what if you wanted to sum the squares of the first billion integers? If you tried on your machine, you might notice that your computer becomes non-responsive. That's because Python is trying to create a list with 1 billion integers, which consumes more memory than your computer would like. Your computer may not have the resources it needs to generate an enormous list and store it in memory. If you do try to do it anyway, then your machine could slow down or even crash. When the size of a list becomes problematic, it's often helpful to use a generator instead of a list comprehension in Python. A generator doesn't create a single large data structure in memory, but instead returns an iterable. Your code can ask for the next value from the iterable as many times as necessary, or until you've reached the end of your sequence, while only storing a single value at a time. If you were to sum the first billion squares with a generator, then your program will likely run for a while, but it shouldn't cause your computer to freeze. I've run this on my machine and I've sped up the video for simplicity, but it did run for a few minutes before it completed. You can tell that this is a generator because the expression isn't surrounded by brackets or curly braces. Optionally, generators can be surrounded by parentheses. This example still requires a lot of work, but it performs the operations lazily. Because of lazy evaluation, values are only calculated when they're explicitly requested. After the generator yields a value, for example, 567 multiplied by 567, it can add that value to the running sum, and then discard that value and generate the next value, 568 by 568. When the sum function requests the next value, the cycle starts over. This process keeps the memory footprint small. The map function also operates lazily, meaning that memory won't be an issue if you choose to use it in this case. Once again, I've sped up the video, but this just ran for a few minutes on my machine before it completed. So which approach is faster? Should you use list comprehensions or one of their alternatives? Rather than adhere to a single rule that's true in all cases, it's more useful to ask yourself whether or not performance matters in your specific circumstance. If not, then it's usually best to choose whatever approach leads to the cleanest code. If you're in a scenario where performance is important, then it's typically best to profile different approaches and listen to the data. Timeit is a useful library for timing how long it takes chunks of code to run. So let's use Timeit to compare the runtime of map, for loops, and list comprehensions. Here you define 3 methods that each use a different approach for creating a list. Then you tell Timeit to run each of those functions 100 times each. Timeit returns the total time it took to run those 100 executions. As the code demonstrates, the biggest difference is between the loop-based approach and map, with the loop taking 50% longer to execute. Whether or not this matters depends on the needs of your application. It's up to you whether you prefer the generator expression or map. Okay, so now you know when you might want to avoid using a list comprehension in Python. Coming up next, we'll wrap things up and review everything you've learned in this course. In this tutorial, you learn how to use a list comprehension in Python to accomplish complex tasks without making your code overly complicated. So now you know how to simplify loops and map calls with decorative list comprehensions, supercharge your comprehensions with conditional logic, create set and dictionary comprehensions, and finally determine when code clarity or performance dictates an alternative approach. Whenever you have to choose a list creation method, try multiple implementations and consider what's easiest to read and understand in your specific scenario. If performance is important, then you can use profiling tools to give you actionable data instead of relying on hunches or guesses about what works best. Remember that while Python list comprehensions get a lot of attention, your intuition and ability to use data when it counts will help you write clean code that serves the task at hand. This, ultimately, is the key to making your code Pythonic. So that just about wraps up this tutorial. I really hope you enjoyed it, and thanks so much for watching.